Hello, everyone. Welcome to our panel. The panel is about blockchain data security and privacy. So let's start the meeting. At first, please introduce yourself and your team. Harry, you first.
Yeah, hi, I'm Harry Halpin. I'm the CEO and co-founder of NIM Technologies. NIM is a private mixnet, a layer 0 solution, sort of like a decentralized VPN for those people that have used VPNs. We did our token sale and CoinList earlier in the year, backed by all the usual cast of characters from Binance to A16. And I'm very happy to be here. I was in Shanghai in 2019. So good to be here virtually, at least.
Okay, got it. So, Emma?
Yeah. Hi, everyone. I'm the CEO of O1 Labs. At O1 Labs, we build zero-knowledge based technologies and blockchains. We incubated the Mina protocol, which is a layer 1 that got launched about a year ago, which is the world's first async chain. And now we're working to enable it with zero-knowledge applications such that people can develop general-purpose smart contracts. And we're doing it via a new SDK called Snarky.js, which allows developers to write TypeScript zero-knowledge based applications. So excited to be here.
Okay, good. Guoyu?
Hi, everyone. I'm Guo Yu, the founder and CEO of Segabit Labs. We focus on smart contract and zero-knowledge proofs. We also help other teams build decentralized tools, libraries, and applications. We also worked on a decentralized protocol for data file exchange using zero-knowledge proofs. Yeah.
Okay, so I'm Blue, CTO of Slowmist Technology. Slowmist was started by a team with over 10 years of cybersecurity to become a global force. Our goal is to make the blockchain ecosystem as secure as possible for everyone. So let's start the questions. The first one, some blockchains are adding privacy, either as an optional feature like easy tag on Ethereum or as a default like in Zcash. Are these blockchains really private? Harry, can you answer the question?
Yeah, I'll give my quick opinion on this, which is that privacy is a holistic property of an entire system. So a lot of people are very, I would say, interested in zero-knowledge proofs, particularly around scaling Ethereum. And they can offer on-chain privacy. So this makes the data on the blockchain private. It's also what, for example, Tornado Cash was doing with the Mixer, which recently got shut down. But the fact of the matter is when you communicate to a blockchain-based system, you're using, for example, peer-to-peer broadcasts, the time of your transaction, the IP address, which geolocates you to at least the city, if not a neighborhood. These are all public. So I think that while zero-knowledge proofs are making great progress, they're not enough, and we need to have different and other kinds of technologies. For example, mixed nets, various kinds of onion routing on the lower levels, and also privacy-enhanced smart contracts and other kinds of technologies on the higher levels to really achieve genuine privacy on blockchain and Web3 in general.
I think one other one is that right now, whatever is live is only with respect to like whatever privacy is live on blockchains is only with respect to token transfers, which isn't too surprising because, you know, most of Web3 is about buying and selling tokens or NFTs. We're still building the application for use cases beyond speculation. And, you know, part of that reason is, well, number one, because zero-knowledge tech is hard to build. So there are a lot of projects that are in the works. But even second of all, like, you know, if you look at, for example, you mentioned Aztec or other layer 2 projects on top of Ethereum, some of which claim to have some sort of privacy, that's actually not totally true because the data actually ends up being sent to zero knowledge proof computation centers or, you know, cloud providers, which, you know, generate proofs on your behalf. And that's because zero knowledge computations are computationally expensive. So many projects haven't been able to, basically bring down the cost of it to be done on average user devices. And that's also something that we're building and almost have ready to be launched, where an average user can, on their average laptop or smartphone, generate zero knowledge proofs for general purpose computation, such that, whether it's to prove any sort of data or attest to any of their data, they can generate the said proof on their devices, send it to the blockchain, such that the blockchain doesn't see anything but whatever they're trying to prove. So, there is multiple layers of privacy that doesn't exist today, but I think it's promising to see, what everyone is building on this panel.
Okay, good. How do you think, Guoyu?
Okay, I think both the Cash and the Ethereum's encrypted with, for example, Aztec or Tornado Cash are not so private in the sense that the accounts on that blockchains are not privacy protecting by default. So users, will have a normal accounts before they enter a shielded or something like, or a protected accounts. So the privacy level will depend on the size of anonymity set. Okay, I think not so many assets or not so many people are willing to enter the private pool. So the privacy will be weaker when less people want to, enter that private pool. So that's why Tornado Cash needs, incentives, encourage people, more people to deposit assets into that mixer or a private pools. So I think, but incentive actually is not that easy to achieve, also considering privacy protecting. So I think the main challenge is how to enlarge the size of an anonymity site or a mixing pool, helping those people who really care about privacy. Yeah, that's my opinion.
Okay, got it. The next question about security. Even if your blockchain is secure, the blockchain relies on the internet. How do you know if your internet connection is secure? Harry, you suggest first.
Yeah, I would just say it's almost impossible for end users to know. So one thing that we have to do as privacy experts and privacy technology companies and startups in Web3 is we need to build both making sure our blockchains are secure, the consensus algorithm, the zero knowledge proofs, the cryptography, in the case of NIM, the mixnet, which mixes the packets and disguises who's sending what packet to someone else. But we also have to have easy to use user signals. So for example, like a red button that becomes a green button. That's, we currently have something similar with NIM Connect, which we just launched a few weeks ago. So users can know if their at least connection to a blockchain is secure. And as shown by Moxie Marlin Spike, that's generally not the case with MetaMask and Infura and the current infrastructure. That's
okay. How do you think, Emma?
Yeah, I mean, Harry and NIM is building, this type of tech that enables it. I do think, to add on top, one other important fact is that the more users can do themselves and on their own devices to connect to a blockchain, the more privacy guarantees they will get. So, part of this is about being able to run full nodes on your own device, because what we saw with Tornado Cash and earlier is also because everyone uses these applications through wallets, which also connect to other full node providers. The minute not only do they have a lot of information about you because you ultimately send your information to them, but they can also censor your access to various applications, or they can censor your transactions, which would not be the case if we're able to run your own full node Now, that doesn't happen today with many users with Ethereum, Bitcoin, and most of the popular chains because it's very expensive or hard, at least, to do that for an average user, right? And that is also a feature or an improvement that Mina enables because the core premise of Mina is what we call a succinct chain, in which the entire blockchain consists of a canonical zero-knowledge proof that always stays, tiny and fixed size, and that provides the same guarantees as a full node on a traditional blockchain. So any user on an average smartphone or computer can download a few kilobytes of data and say basically, okay, the instance of this blockchain that I have been sent is actually true. It's the right one. I'm not being scammed or duped. So I can try to send a transaction or believe the account balance or other facts that I'm seeing. So yeah, the more the user can do, the better it is for privacy. And these types of technologies that we're all building are meant to enable that.
Okay, interesting. So Guoyu, your turn.
Okay. Okay, it's really a good question. That I think the infrastructure of the whole internet is not secure. Generally, I think the initial design idea of the internet protocol, many protocols do not take the security into account, or so-called not the Byzantine fault tolerance. They assumed that 99% of users are just good guys. For example, they spam emails everywhere today, and we are facing many attacks around us. For example, the eclipse attacking may be possible, and the points by DNS servers, something like that. I think it will take time to longer than we expect to rebuild the internet protocol from the scratch, or to a blockchain center something like a new internet. So the other thing that I'm now worried about recently, that is my web browsers in my mobile phone keep seeing that some websites I'm going to visit are harmful to me, but I have no idea about that. I'm also not sure if the website is harmful, really harmful to me, or is just censored by some unknown authorities. It's kind of terrible. I have to, do a lot of research work before I click that go ahead, something like that. So I think, yeah, I think the internet connection, I think underneath the blockchain are not so secure. So that's what I'm worrying about. That's it.
Okay, that is a question for Emma. So ZK Tech is portrayed as the main solution to scalability challenges. What else is it good for? How important is it for Web3 and the broader tech world? So Emma?
Yeah, so it's such a foundational tech that there's likely many use cases that we haven't even figured out yet. But when you take a step back, first of all, for the audience, what is zero-knowledge tech? It comes from zero-knowledge proofs, which is a family of cryptography, which states that, or which comes with a property where you can basically prove the validity of a computation. So with many other older types of cryptography, such as public-private key cryptography, you're basically able to prove the ownership or of a piece of data, essentially, when you sign a piece of data, right? Whereas with zero-knowledge proofs, you prove that a computation has been done correctly without having to disclose its innards or the input that it went to it. So, which is a fundamentally new capability and is ever more important in a world where, all of our computation is being done up in the cloud by devices and information owned by centralized parties. So that's why, the pure ability of zero-knowledge proofs to fight against this gravity is very important for blockchains as well, because obviously blockchains are all about, and our industry is all about decentralization and giving power back to the users. So, as you alluded to, there's been a lot of hype around ZK's applicability for scalability challenges because without going into too much detail, it essentially enables more throughput to be given to blockchains without trading off decentralization. Beyond that, we believe privacy, especially around data privacy, is very important. Another very important application area, especially because a few years ago, and I at least have been in this space for long enough now to see, like there is always a next big thing that is going to solve all of our challenges and make crypto be used by hundreds of millions of users. Beyond buying and selling assets, that hasn't happened yet. Scalability was seen as the next big thing. We have scalability now, right? There's many new blockchains that have a lot of TPS. We still don't have wide adoption. So we believe privacy and then being able to treat users as data privately is the next big enabler, because if you look at any sort of DeFi application, social DAO type applications, NFTs, in order to participate, you basically have to put in a lot of money, right? You either have to open a collateralized debt position, or have to buy an NFT, or have to buy an NFT to prove you're a part of a DAO, right? Like Nouns DAO and all these projects, you have to have tens of thousands of dollars. So they basically become, either like these yield farming things for large institutions, or toys for rich tech people. We have to have useful applications like in the general world, in the normal world, where an average person can go and apply to be underwritten, to be given an uncollateralized or undercollateralized loan. Or people need to be able to prove that they belong to a group, right? Whether it's a citizenship to a country, or they work at a company, or they're at a university, or they graduated from a university. None of this information is available right now, because the minute you put anything on a blockchain, it's public for anyone to see forever, right? Like if you share your address today, everyone can see how much money you have and where all the trades and all the transfers you ever did. For some people, it's okay, because no one puts actually valuable real life information onto these blockchains. Like you don't know the credit score of a person, how much salary they're making, which school they graduated from, what career path they followed. And in order for more useful applications for the general populace to be available, these types of information are needed. You can't just ask everyone to put up a lot of money. So that's why we believe privacy is really, really important for wide adoption. And zero knowledge tech, we believe, is the core technology that will enable these types of information, data, and computation to be brought on chain, right? Such that we can have these sorts of general Web3 applications where our parents, your friend who doesn't care about crypto or tokens, can come in and do the things they want to do, but in a more accessible way, in a more fair way, and also have more innovative applications. So yeah, we believe this is like truly very powerful for the future of our industry.
Okay, thank you, Emma. So another question for Harry. How can blockchain technology help the entire internet become more secure for traditional companies?
Yeah, I mean, I think I'm just going to build off of what Imre said. We have all this new foundational tech coming. It's great, it has lots of Web3 applications, but let's think about what happened to the internet before blockchain technology really took off, in the last few years. We had the Snowden revelations. We had the revelations that the United States government was essentially spying on most major internet transactions and recording them all. Recording internet data is very cheap. Then later you can do machine learning or AI analysis on it. And this is a violation of my individual freedom. It's the violation of the sovereignty and freedom of other countries. People in, for example, South America were very upset that the United States was doing this. And now this kind of mass surveillance of internet traffic is becoming something that's within the capabilities of smaller actors. Even, for example, cyber criminal actors. It's going to become easier and easier to do. And this is a problem which affects not just Web3, but it affects all of humanity on the internet. It affects traditional governments. For example, NIM was backed by the European Commission. currently hired the ex-central banker of Ecuador, who's working to build privacy-enhanced CBDCs. It's affecting the whole planet. And also, even traditional companies like Apple and Google are now trying to somehow become more private, even though at least with Google, it's problematic because their business models effectively mass surveillance and advertising. So the entire internet has this kind of privacy problem, and no one is working on it from traditional Silicon Valley. Very few people on the internet actually work on good defense from government agencies. They mostly work on offensive capturing of data of enemy governments and individuals. So to be honest, Web3 is going to produce the privacy tech, not just users, but also governments, companies, institutions will be using and build into the foundational protocols of the internet via standard bodies like the Internet Engineering Task Force, which NIM is currently working with on our mixednet packet format. Yep.
Okay, got it. Thank you, Harry. Okay, that is the last question for Guoyu. Okay. Web3 aims to protect the user's data, but the data is stored off-chain because the cost of off-chain storage is high. Is there any approach to utilizing personal data through blockchain while protecting privacy?
Okay. Okay. Generally, we need two key tools. One is sort of on-chain anchors of data. The other is efficient ZK proofs about the off-chain data. So an on-chain data anchor can be a SHA-256 hash of a chunk of data, for example, or it can be a cryptographic commitment, for example, a Python commitment or a KZG10 commitment. But for a huge data file or database data set, we probably need Merkle tree with knowledge proofs, or something like a Virtual tree, more advanced tool. The anchor size should be small enough so it can be put on chain with a low cost, but it has to be bound to the original data. That means if data is updated, then the commitment will change to another one. But also the commitment or the anchor should be hide any the knowledge or the information from that original data. Okay. The other technique is about the ZK snark, which can ensure that data integrity with respect to the data anchor. Besides, ZK snarks can use the off-chain data in a way of privacy protecting. So what I was saying is a general framework to we put a lot of data anchor on chain while we operate or process data off chain. So regardless how large the data set of chain is, but we have many challenges ahead. Okay, first of all, the data of chain, it keeps changing frequently, and we have to invent something new to low cost update the data anchors on chain, so make them synchronized between the data anchors, the data commitments between the data off chain. So there are things that we have to find a new knowledge proof techniques to process large amount of data a short of time, or keep the speed, keep the pace of the data updates, off-chain data kind of updated every day, every minute, So the problem that actually we are solving recently actually is how to generate the knowledge proofs for the large amount of data. For example, the data with rich structure, like for example, a couple of data table, and they are related with each other. So we have to process data with statistics, queries. We sum them together, or calculate the average of a list of, for example, a column. So the one work we achieved last year is we find out a new zero-knowledge proof generation approach for large chunk of data. How large it can be a couple of gigabytes. So actually, our new zero-knowledge proofs specialized in processing parallel data, and the data processing can be layered. So I think that's a general pattern for data processing, like a MapReduce pattern. So I think, okay, most of data processing can be categorized into the MapReduce pattern, or MapReduce after MapReduce. Okay, so last year we implemented a demo, so we can quickly query or statistics on a data table with a couple millions of data records. So to generate the zero-knowledge proof very quickly. So you also implement data processing using the deep neural network. For example, we can prove the image recognition from the VGG 16 test set in just a couple of hours. So the zero-knowledge proof circuit can be a couple of several billions of gates, multiplication gates. So now we're currently doing actually is continually optimize the whole framework. So we introduce many new cryptographic tools, done by Ethereum foundations, that guys, to change the underlying the crypto. We use new cryptographic commitments to replace the old one. So we can improve that performance a lot. So we can using that new zero-knowledge proof tool, so we can easily exchange data between users by help of some smart contract, or we can input a lot of off-chain data into some smart contract to build bigger or more applications besides DeFi and NFT. So that's what we are doing right now. So we can also easily to prove the historic data. For example, blockchain, the Ethereum, so prove that people, they have some historic records online on chain, so prove their identity or their assets holding, something like that. Yeah. So I think the future will be, differently after, more zero-knowledge proof related tools or new schemes, coming from the community. That will be exciting. That's it.
Okay. Thank you, Guoyu. I think that's all questions. Thank everyone for your time. Okay.
Thank you. It's
everyone.
been an honor.